This is right in the middle. Today I'm going to go through 8-1 on page 399, logarithm and logarithmic functions. So I know I didn't finish all of chapter 7 in videos. 7 was exponents, and you need to know those exponent properties to apply to logs. Logs are just another way to write exponent equations. So the exponential graph and a log graph, or the functions, are inverses of each other. So remember, inverses reflect along the diagonal. So this one right here is exponential, 2 to the x. And this one, when we do the inverse, remember you switch x and y and solve for the y. They didn't switch x and y. They just solved. Well, I guess they did switch x and y. That's all they did. But anyway, this is a logarithmic graph. So notice exponential, remember it wouldn't cross the x-axis and goes through 0, 1. This one doesn't cross the y-axis. The y-axis is the asymptote because it gets really close to it, and it always goes through 1, 0. So to do transformations, you always go through 1, 0, the x, and exponential goes through 0, 1. Okay. The easiest way for me to show you, here's one. You just rewrite an exponent. So we'll do this and then I'll show you the format. So anyway, you start at the base, exponent, answer. So this is 2 to the y equals 16. Your answer is part of the log. The whole reason we have logs is because if you have, we had the zombie project that you had multiplying by 3, started with 5. How many days did it get to 8 billion? This is the whole reason we have logs. We are able to solve for that precise x value with the log. Without the log, you just have to multiply over and over and over till you get to 8 billion. So all logs are rewriting an exponent. So here's one, 2 to the y equals 8. So you're going to always have your log, your base, your answer, and it's going to equal your exponent. So base is the bottom number. Usually exponent is small, but now with the log, the base is small and exponent is a large number on the right. I'm going to draw this in between. And your answer is whatever to the exponent is your answer. So for example, if I have 2 to the 3 equals 8, well, that's kind of the one they did. This is log base 2 of 8 equals 3. Exponent's all by itself. The base is down on the bottom. So if you put this in the calculator, you will get 3. Okay. So let's rewrite some. We could go exponential form or log form. I do not like that they put the equals first, so I'm going to cross those out and rewrite it myself. So you start at the base, and then you get your exponent, and then you get your answer. So base, exponent, answer. And that is true. 4 cubed is 64. Base, exponent, answer. So 3 to the negative 5 is 1 over 243. True, because it's a negative, so it flips it. Base, exponent, answer. 9 to the 1/2, which is the square root, is equals 3. Okay, so let's rewrite this one. Base, exponent, answer. 125 to the 1/3 is 5, and 1/3, remember, is the cube root. And that is true. So you do have to remember that cube root is 1/3, square root is 1/2. All right. So now let's write the other way. Let's start with exponent and write it as logs. So here's your exponent. Now they almost finished it, but we're going to start on base, go to the right, and then write the exponent last. So base, answer, exponent last. Base, answer, exponent last. base, answer, exponent last. Okay? This one they didn't do, so we start on the base, answer, exponent last. So log, our base is 2, our answer is 512, and that equals 9. All right, let's do the think about it. I'm going to try to fold this way. So we write it as log, so we have log. What's our base? Our base is here. This is our exponent, so we have 2z plus 5. Our answer is 8. Our exponent is 3. Now, since this is exponential, the inverse, there are things that sometimes are not true. We never really have a base of 1 or 0. Okay, so we never see 1 or 0 right here. Another thing, we have log base 10. Sometimes they don't write the 10. Actually, a lot of times. They don't write the 10 as the base, it's just this. Okay, so in the calculator, if you don't put a base, it's base 10. The other thing is, if your base is positive, no matter how many times you multiply, your answer will be positive. So if I have log 5, I'm going to put D, I don't know, just for a different letter. This answer, since my base is 5, no matter what my exponent is, D is never going to be negative, always going to be positive, because 5 times 5 times 5, no matter what the exponent is. And D will never equal 0 because of that asymptote. You can't multiply 5 by itself and ever get a 0. You always get a positive number because this base is 5. Okay? All right. To evaluate them, you get the same base like you did with an exponent. So this one we rewrite exponentially. So 216 to the y equals 6. I would have switched sides, but it's fine like this. So 6 is itself its own base, but 6 cubed is 216. Then you set your exponents equal together and you get this answer. Now your calculator, you could enter this like this, 1/3. Your calculator will probably give you this. I don't want to see this because this is a decimal. It doesn't tell me which root. This 1/3 tells me the cube root of 216 equals 6. So make sure your answers are in fraction form. If you don't know that 0.33 is 1/3, then you could do menu, number, change to fraction. Okay. Find the inverses. Okay, so this is a formula. The air pressure outside an aircraft can be determined by the equation this, where B is the air pressure at sea level and H is the altitude in miles. If the air pressure at sea level is 14.7, so that is our B, write an equation to find the height of the aircraft when the air pressure is known. So here's our formula. There are 3 variables there, so there's no way we could solve and get a number out because we're still going to have something missing, but we do know B is 14.7. So in order to write to log form, you cannot write this into log form yet because you have more than just your base and exponent. That 9, this is all the exponent. So you got to get rid of this. So we're going to divide both sides by 14.7 and we get this part. Now we have base, exponent, and answer. So we could rewrite it as a log. So exponent is over by itself. This is the log. My base is 10. My answer is P over 14.7. Now we have this. We're trying to solve for H. So we multiply it by the reciprocal because we divide, so we multiply, so we divide. And we end up with this as my formula for H. So now if I get the pressure outside, I could find the altitude. Okay. Tornadoes. The distance in miles the tornado travels is this. So this is this exponent, where W represents the speed of the wind in miles per hour. Write an equation to find what W is. So we're going to rewrite this as log. So we're going to say log base 10 of Y equals my exponent. Now we want to get W by itself, so we're going to multiply by 93. Multiply by 93. Now we want to get W by itself, so we've got to add 65. So we have to add 65 to this. Two ways you could write it. You could write 65 plus 93 log 10y. Or you could write the 65 after, but just make sure you have parentheses that it doesn't go into your log. So you get 93 log 10 of y plus 65. When you're entering the calculator, make sure this is outside the log. So now they gave us a y of 50. When you plug in 50, again, the calculator, you don't have to put the 10. You should get 223 miles an hour. Okay, so you put this in the calculator. All right, now we're going to look at the graphs real quick. Graphing, like I said, it's the inverse. So remember exponential? Exponential, we had two different graphs. We had this for growth and this for decay. And it all matters on our rate. Our rate was greater than 1 here, and our rate was a fraction between 0 and 1 here. Okay? That's why we have two different graphs for log. It matters on the base. So base, this is the inverse of growth. And this one's the inverse of decay. And both of them don't cross this y-axis. That's your asymptote. And behavior, this goes off to infinity. The left side, look how they note the left side. Left side approaches from the left or approaches from the right. But I do want to bring up the y-intercept. I don't know how to ignore it. I'm sorry. The y-intercept is, there is no y-intercept. That's the asymptote. The x-intercept is 1, 0. Okay? So it always crosses through that 1, 0. I don't know how many times it's going to ring. I'm sorry. Oh, there it stopped. Okay, so transformations, just like any other function, we have outside and we have inside. Inside is left and right. And remember, it's opposite of what you think. Outside is up and down, and outside is reflect and dilate, this one. Okay? So you could think of outside of being vertical, inside is horizontal. So if we had another number in front of that h, that would be a horizontal stretch and reflect. You could graph them in the calculator. Our base here is 6, so this is going to be opposite of growth. It goes like this. Since there's no h, no k, no a is 1. It's just the regular graph with no y-intercept. Your x-intercept is 1. Your domain is all numbers, all positive numbers, because it's not over here on the left. Range is all real numbers. Here's your left and your right. Oops. Here's your left. It approaches 0 from the right. And your right hand end behavior, which is this one, goes to infinity. Okay. So it's approaching 0. The other example had C. This one has a base of 1/4, which would be a decay problem. So it looks like this. Again, here it approaches from the right, it goes to infinity because it's going up. This one on the right side is going down to negative infinity. The domain is positive numbers because it's on the right side. The y-intercept is non-existent because it doesn't cross. The x-intercept is 1. All right, here's some transformations. The easiest thing is to do the graph and then see, but we know our h is -3, our k is -1, and our a is 2. All right, that is all I'm going to go over today. Your assignment is 1 to 23 and 37 to 42. Let me know if you have questions. I'm sorry about the phone ringing.